Hello everyone, welcome back to my channel Code and Prep. In this video, we are going to understand microservices architecture, one of the most popular and powerful architectural style used in modern software systems. Big companies like Netflix, Amazon, Uber uses microservices to handle millions of users daily. By the end of this video, you will understand what microservices are, how they work, their advantages and challenges, and when you should actually use them. So let's get started. So what is microservices architecture? In traditional systems, we build one large application that handles everything, user management, orders, payment, inventory, all inside a single code base. But in microservices architecture, we break that big application into smaller independent services. Each service focuses on one specific responsibility. For example, user service handles user registration and login. Order service handles order processing. Payment service handles transactions. Each service runs independently and communicate through API gateway. This gives us a flexibility and scalability. So why we should move away from monolithic architecture? In monolithic architecture, everything is tightly connected. If the payment modules needs more performance, you must scale the entire application, even if other modules don't need scaling. Deployment is also risky. A small change requires a redeploying the entire system. As the application grows, the code base becomes huge and difficult to manage. Microservices solve these problems by breaking the system into manageable piece of code. Now, this is a typical microservice architecture diagram. Let's understand it step by step. At the left side, you can see we have clients, web app, mobile app, or external systems. A request first goes to API gateway from any of the client. Then API gateway act as a single entry point for all clients. It then routes the request to appropriate microservice. Each microservice has its own database, and this separation ensures independence and scalability of application. Now, here we can see the detailed explanation of architecture diagram. First is a client layer. The client sends the request. Then the API gateway, which is the second point here. The API gateway receives it and performs like authentication, routing, rate limiting, logging, etc. Then it forwards request to the correct service. So on basis of API gateway decides which service to call, and it sends that request to appropriate microservice. Then after that, each microservice is responsible for its own data and logic. For example, order service does not directly access payment database. So if service need to communicate, they use REST APIs or asynchronous messaging like Kafka or RabbitMQ. So this ensures a loosely coupled application to be loosely coupled. Now, let's see some of the key characteristics. So, each service can be deployed without affecting others. You can update the payment service without redeploying the entire system. Then, each service can use different technologies. For example, user service in .NET, payment service in Node.js. If one service fails, other can continue working. So, it improves fault isolation. Now let's walk through a real example. User places an order. Okay, so the request goes to API gateway. The API gateway forward it to the order service. Then order service may call payment service to process the payment. Then it may call inventory service to reduce stock. Then after that, after everything is succeeded, the response is sent back to the client. This distributed process makes the system flexible. So, advantages of using microservices architecture. So, microservices allows you to scale only the services that need scaling. Large organization can assign a separate team to different services. Continuous deployment becomes easier because you deploy small service independently. So that when you deploy small services independently, there are very less chances that other things are breaking after deployment or anything happens inside in the deployment. Then It fits perfectly with cloud environments and containerization tools like Docker or Kubernetes. Now let's see some of the challenges of using microservices architecture. Microservices are powerful but not simple. You must handle network communication between services. Monitoring becomes complex because logs are distributed, and managing distributed transaction is challenging. You need strong DevOps practices to manage the deployments. So when should you use microservices? If you are building a small internal tool, microservices might be unnecessary. But if you are building a scalable cloud platform with multiple teams, microservices are a great choice. Now, to summarize, microservices architecture breaks a large application into small independent services. It improves scalability, flexibility, and team productivity. But it also increases complexity. So, always choose architecture based on your business needs and not a trend. If this video helped you to understand microservices architecture, like, share, and subscribe for more software architecture and .NET content. Thank you.